Picture yourself inside a small, lit cabin. The hum is steady. Through a thick pane of glass on your left, a pale blue marble drifts away from you. Slowly, with no sound at all. That marble is the Earth, and you have just left it. Ahead, somewhere in the dark, is the planet you have agreed to visit. Its name is Saturn. You have boarded the spacecraft. Now the math begins. This is not a question of technology. This is a question of distance. And distance does not negotiate. What follows is not the story of whether humans will ever fly to Saturn. The story is whether you, the person now sitting in that cabin, would arrive alive, and whether anything that could be called arrival would be waiting on the other side. The truth is sobering. Step by step, the universe takes away every assumption the films have given you. The average distance between the Earth and Saturn is 1.43 billion kilometers, about 9.5 times the gap between the Earth and the Sun. Light itself, the fastest thing the universe permits, needs about 1 hour and 20 minutes to cross that gap in one direction. So if you send a message home from your cabin, a short voice note saying you are fine, the reply will reach you in more than 2.5 hours. That is roughly the average wait for a routine GP appointment on the NHS. Only this time, the wait is the sound of your own voice traveling out to Earth and back. And that is light. You are not light. The only spacecraft ever to enter orbit around Saturn was Cassini, launched in October 1997 and arriving in July 2004. 6 years, 8 months, 16 days. Almost 7 years in one direction. Along the way, it covered roughly 3.5 billion kilometers because it could not fly in a straight line. It needed 4 gravity assists. Venus, Venus again, Earth, then Jupiter, just to be flung outward fast enough. Its average speed across the whole trip was about 16.4 kilometers per second. Your cabin would need to do something similar, except you also need to come back. Voyager 1 reached Saturn in about 3 years. But Voyager 1 did not stop. It flew past. If you only want to wave at a planet through a window, 3 years is the price. If you want to slow down and stay, the price is paid in fuel. Saturn's escape velocity at the cloud tops is around 36 kilometers per second, about 130,000 kilometers per hour. To be captured by Saturn's gravity, your cabin has to drop below that figure, with precision, against the deepest gravity well in the outer solar system, with no atmosphere thick enough to brake against. The only thing that can slow you is your engine firing backwards, burning propellant you had to drag across 3.5 billion kilometers in order to use here. This is what Tsiolkovsky's rocket equation tells us in a single line. Every kilogram of fuel you want to burn at Saturn is a kilogram you first had to accelerate from Earth. Arrival is a second journey, just as expensive as the first. Now assume you have done it. You have arrived. You have slowed down. Your cabin is in orbit, and you look out of the window for the place where you will land. There is no place. Saturn is a gas giant. It has no solid surface. Below the visible clouds, the atmosphere does not stop. It thickens, smoothly, into liquid hydrogen, and deeper still into metallic hydrogen. No shoreline, no plain, no rock. By convention, scientists draw Saturn's surface at the level where atmospheric pressure equals 1 bar, the pressure at sea level on Earth, a line drawn for the sake of having numbers. Below it, the pressure rises past 1 million bar. The atmosphere is 96.3% hydrogen and 3.25% helium. Winds at the equator move at up to 1,800 kilometers per hour. The temperature at the cloud tops is minus 178 degrees Celsius. No human spacecraft has ever attempted to land on Saturn because there is nothing to land on. A probe simply falls and is crushed and is dissolved and stops existing. Landing on Saturn is a category error. There is no there. Fine. Assume you never planned to land. You planned to stay in orbit and look at the rings. That, after all, is the postcard. The rings of Saturn span almost 26 million kilometers across, made of about 99% water ice. Particles ranging from dust to chunks the size of a house. Vertically, the main rings are only 10 to 100 meters thick. From the side, they almost vanish. From above, they look like the planet is holding a sheet of glass. That sheet of glass is also a wall of debris. In April 2017, Cassini began its grand finale. 22 dives through the narrow gap between the planet and the innermost ring. The relative speed inside that gap was around 124,000 kilometers per hour. At that speed, you would cross the United States, from New York to Los Angeles, in less than 2 minutes. At that speed, a single grain of dust striking the spacecraft has the kinetic energy of a bullet. Cassini flew with its 4-meter main antenna turned forward, used not as a dish but as a shield. It survived 22 of those crossings. On the 23rd, on September 15th, 2017, Cassini was steered into Saturn's upper atmosphere and burned, deliberately, to keep its metal away from Enceladus and Titan. The rings are beautiful. They are also the reason your cabin would never get close enough to see them properly. Suppose, somehow, you slip past the rings. What waits on the other side is something you cannot see and cannot dodge. It is radiation. Saturn's main radiation belt extends more than 285,000 kilometers out from the planet's center. During its final dives, Cassini discovered an inner belt nobody had predicted, full of protons with energies reaching into the giga-electron-volt range. In that environment, electronics do not slowly fail. They experience what engineers call single-event upsets. One high-energy particle striking a transistor and flipping a bit. One particle. One mistake. For a probe, this is a problem. For a human nervous system protected by skin, bone, and a few centimeters of aluminum, the calculus is harder. The only place in the Saturn system where human hardware has ever touched a solid surface is Titan. The European probe Huygens descended through Titan's atmosphere on January 14, 2005. The descent took about 2 hours and 27 minutes. It landed at minus 179.3 degrees Celsius, the temperature of liquid nitrogen. Once on the surface, it transmitted for about 72 minutes, until Cassini moved over the horizon and the link was lost. Due to a configuration error, one of its 2 radio channels was never switched on, and half the data was lost forever. 72 minutes. 2 pints at the pub before last orders. That is the entirety of time that human-made equipment has spent operating on a solid surface anywhere outside the Earth-Moon system. By now, some viewers are typing. The objections are predictable, and they are fair. They deserve to be addressed. The first is artificial gravity. A spinning ship, the argument goes, would solve the biology. The muscle loss, the bone loss, the cardiovascular drift over 7 years of weightlessness. And that is correct. The principle has been understood since Tsiolkovsky and Sander wrote about it in the 1920s. On paper, the problem is solved. The minimum radius of rotation for 1G without making humans sick is somewhere around 200 meters. The International Space Station is 109 meters long, end to end, and does not rotate. No rocket flying today can lift a single rigid structure of the required radius. 100 years on paper, 0 years in metal. The second is nuclear or ion propulsion. Surely a better engine cuts 7 years down to 1 or 2. Partly true. Nuclear thermal and ion drives do produce a higher specific impulse than chemical rockets. NASA's Dragonfly mission, approved in 2024 and scheduled to launch in 2028, will arrive at Titan in 2034. 6 years of flight. The best real engineering estimate currently on the books. It is also still launching on a chemical rocket and using gravity assists, because crewed nuclear propulsion is not yet certified. Between Cassini's destruction in 2017 and Dragonfly's planned arrival in 2034, there will be 17 years with no human-made object operating in the Saturn system at all. That is the actual pace. The third is the future. 100 years ago, humans could not fly. Give us another 100 years. This argument has weight. The leap from the Wright Flyer in 1903 to Apollo 11 in 1969 is real. But the gap between Kansas and Saturn is not an engineering gap. It is a physics gap. Faster than light is not allowed. Biology in a high radiation environment for 10 years cannot be wished away. And no amount of progress can put a surface on a planet that does not have one. Progress can shorten the trip. It cannot give the destination a ground floor. You are still in the cabin. You have been there for the entire length of this video. And in that time, you have not moved 1 light second from the place you started. The Expanse, the most carefully written science fiction series about the outer solar system in the last decade, shows lived-in stations around Saturn's moons and human colonies on Iapetus. It is set 200 years after the moment in its own fictional history when humanity had already crossed the 3 barriers we have not crossed in reality: distance, radiation, and the absence of a surface. The show is honest about what it skips. We have skipped nothing yet. The planet you are flying towards receives about 1/100th of the sunlight that falls on Earth. Its cloud tops are at minus 178 degrees Celsius. And yet it radiates back into space about 2.5 times the energy it receives from the sun. Heat left over from its own slow, ancient collapse. The destination sold to you by the films is the warmth of a planet still cooling from its own birth, 4.5 billion years ago, with nowhere on it for a human being to stand. And so your cabin turns around. You do not land. You do not stay. You begin the long return, because home is still in only one place. Most people who have ever lived have only seen Saturn the way Galileo saw it through a 4-centimeter lens in 1610, as a small, ringed shape in a dark sky, looked at from the only ground in the universe that holds them up. That, in the end, is the relationship between humanity and Saturn. Not a rival, not colonization. Looking. Saturn was never a destination. It was a reminder. And the reminder is this: the only world that lets you stay alive on it is the one already under your feet.